Okay, today I'm going to talk about section 2.5, the chain rule. This is like some of the outline. So first, I'm going to talk about the chain rule. The second, the power rule combined with the chain rule. Third one, I'm going to give some examples to you. Okay. This is the first example. F of x equals square root of x. You can take a derivative. F prime of x is square root of x prime. So what is the answer? The next one. You can change it to the x to the power 1/2 prime. You can use power rule. 1 over 2 is down. X to the 1 over 2 minus 1 is 1 over 2. X to the negative 1/2. The change back to positive exponent. The 1 over x to the 1/2, the change back to radical form, so we have it. So exactly 1 over 2 square root of x. Exactly, this is Kashad class, right? The Kasha covers this kind of things, I think. So we have it. The g of x equals x squared plus 1. What is g prime of x? Do you know what is g prime of x? Could you write your answer on the chatting board? What is x squared plus 1 prime? What do you think? Do you know x squared plus 1 prime? Do you know the answer? Could you write the answer of g prime of x on the chatting board, please? Do you have any idea? This one? The 2x is right? 2x? Yup, this is 2x. This is same to x squared prime plus the 1 prime. Was it like x squared prime? Here, you can use power rule. X to the n prime is the exactly same to n times x to the n minus 1. So this is same to 2 is like down x to the 2 minus 1. One more. What is a constant prime? The constant prime equal to 0. So we have plus 1 prime is like 0. Exactly 2 times x. Yes, 2x. This is like g of x. It's good. How can you find the derivative with the composite function f of g of x? You can plug this g of x into here. So what does it mean? You can plug g of x into x. So exactly the square root of x squared plus 1. What is derivative? This equation. Equation is what is derivative? What is like a derivative? This is equation. You have to use the chain. What is like a chain rule? I can write here. If the g is differentiable at x, what does it mean? The derivative exists. Derivative exists. And f is differentiable at g of x. Then the composite function f equals f circle g defined by capital F of x equals f of g of x is differentiable at x. So f prime is given by the product. F prime of x equals f of g of x prime, exactly same to f prime of g of x times g prime of x. So we have Leibniz notation. So you can write y equals f of u equal to g of x. So we have dy over dx is dy over du times du over dx. So why this is true? Here, we can replace. Here, the y is f of u is g of x. You plug u into here, what happens? Same to f prime of u times g prime of x is exactly same. I can derive. So I can change it. What is f prime of u? F prime of u is y prime. So we can use Leibniz notation. This is dy over du times g prime of x is here. G prime of x is u prime. So u prime is du over dx. So we have this result. So like this. This is exactly same. Same. So we call chain rule. How can you prove this kind of things? Right here. Proof is like this. You can define delta u and delta x. The delta u is the change in u corresponding to a change of delta x in x. So we can derive delta u equals g of x plus delta x minus g of x. We can define the delta u. The corresponding change in y is delta y equals f of u plus delta u minus f of u. Why this is true? So from the previous one, we can use this notation. Y equals f of u, u equals g of x. So we can just check dy of dx equals dy of du times du of dx. I'm going to check these kind of things here. So what's that? I can write here. So u is g of x was like y equals f of u. So we have these relations, so like this. So I want to find the dy over dx. How can you find the dy over dx? dy over dx is use definition. Limit delta x approach 0 exactly delta y over delta x. This is same to limit delta x approaches 0. I can change a little bit. This is delta y over delta u times delta u over delta x. This is possible because delta u is crossed out exactly same to delta y over delta x. The next, distribute, limit. This is same to limit delta x approaches 0, delta y over delta u times limit delta u over delta x approaches to 0. The next one, here, the delta x approaches 0, the delta x approaches to 0. So my question is, what happens delta u? What's that? So what do you think? Delta x approaches 0, what happens delta u? Do you have any idea? The delta x approaches 0, the closer to some value, right? What is the sum value? So what is the sum value? What is the value? What is the value? What's that? You can use this one. Christine said 0. Yeah, makes sense. Here, delta x approach what? 0. What happens to delta u? This is going to 0. Delta x approaches 0. So remaining part is g of x minus g of x approaches to 0. So that's it. So we have 0. Delta u approaches 0. So what does it mean? You can change it. Limit. The delta x approaches 0. You can replace by delta u approaches 0. Delta u approaches to 0. The delta y over delta u times limit. Delta x approaches to 0. Delta u over delta x. The next one, you can change it back to like derivative notation. What is the limit delta y over delta u as delta u approaches 0? Exactly same to dy over du times here limit delta u over delta x approaches 0, we can have du over dx. That's it. I proved. This is idea for proving this chain rule. Like this. All right. So next one. We are going back to previous example. The f of x equals square root of x, f prime of x equals square root of x prime 1 over 2 root x. The g of x is x squared plus 1. The g prime of x is x squared plus 1 prime equals to 2x. We are going back to previous example, exactly same. So how can you find the derivative of the composite function f of g of x equals square root of x squared plus 1. So here, use the chain rule. Chain rule is this one. F of g of x prime is f prime of g of x times g prime of x. So we call chain rule here. So what's that? F of g of x prime is, we have f prime of g of x times g prime of x. So you need to memorize it like this one. Outer function of inner function prime is the outer function prime times inner function prime. So exactly. So outer function of inner function prime is exactly like outer function prime times inner function prime. This is idea. This is idea of like a chain rule. So how can you apply this one here? So what's that? It's the same to f of g of x prime, right? So we have this one, the same. We can use chain rule. So like this. What's f prime? F prime is here. F prime of x is 1 over 2 root x. You plug g of x into x. You can plug g of x into x. You can plug g of x into x. You plug. So we have f prime of g of x is exactly same to 1 over 2 times square root of g of x times g prime of x is here. G prime of x is 2x. We have 2x. You can cross out 2x over square root of g of x. What's like g of x? G of x is given. G of x is x squared plus 1. You plug into here. X over the square root of x squared plus 1. That's it. This is the idea for finding f of g of x prime. So we call chain rule. This is like a chain rule. So what do you think? It's good? So far so good? So do you have any questions so far? It's good? Sure, no problem. I will give you more examples. Don't worry. I will give you more examples today. Here, so like this. So we think about some special case. This is like very useful. Power rule combined with a chain rule. F of x equals x to the power n. F prime of x equals n times x to the n minus 1. F of g of x prime is f prime of g of x times g prime of x. So you plug the g of x into here. Plug into x. So what's that? F of g of x is same to g of x to the power n. So my question is, what is g of x to the power n prime? right? Same to this one. F of g of x, sorry, f prime of, sorry, f is here. This is the same to f of g of x prime. You can use chain rule. F prime of g of x times g prime of x. What is f prime of g of x? You plug g of x into f prime. You plug g of x into f prime of x. You plug g of x into x. So first part is same to n times g of x to the power n minus 1 times remaining part g prime of x. That's it. This is the rule. How can you find g of x to the power n prime n times g of x to the n minus 1 times g prime of x? So we have this one. So you have to memorize this power rule combined with the chain rule. G of x to the power n prime is n times g of x to the n minus 1 times g prime of x. Now, I'm going to give you one example. So here, how can you use this kind of things? Here, x squared plus 1 to the power 6 prime. So what's that? This x squared plus 1 is exactly same to g of x. The 6 is like power n. So what's that? Power n is down. So power n is down times g of x is inner function x squared plus 1 to the power n minus 1. Exactly 6 minus 1 times inner function prime. Inner function is x squared plus 1 prime. Like this. So we have 6 times x squared plus 1 to the power 5 times x squared plus 1 prime is, we can use power rule again, 2x. You're right. So combine. 6 times 2x is 12x times x squared, 1 is here, plus 1 to the power 5. That's it. That we call power rule combined with a chain rule. So this is like idea for solving this basic problem. So we are going back to previous example. Remember previous one here? This previous one, this one. So how can you solve this problem very easily? So we can use power rule. So change it to the power form. Exactly same to x squared plus 1 to power 1/2. You can use power form prime. This 1/2 is exactly log of n. N is like down. 1 over 2 is down. X squared plus 1, keep inner function, was like a power n minus 1. Exactly 1 over 2 minus 1. This is like first part. Times inner function prime. Inner function is x squared plus 1. So we have x squared plus 1 prime. So what's that? This is same to 1 over 2 x squared plus 1 to power 1/2 minus 1 is negative 1 over 2 times x squared plus 1 prime is 2x because x squared prime is 2x, 1 prime equal to 0. Next, 2 is crossed out. So we have x squared plus 1 to power 1/2 times x. You can change negative exponent to the positive exponent, 1 over x squared plus 1 to power 1/2 times x. So 1 times x is just x. You can change it back to radical form. This one is the square root of x squared plus 1. That's it. This is the idea. By using power rule combined with the chain rule. Do you understand this kind of rules so far? It's good? Do you understand this kind of things? Okay. How about some other guys? Kind of? Yeah, don't worry. I will give more examples. So, yep. So like this. So one more. The consider derivative of f of g of h of x prime. How can you find? So you can use this rule. Was it like a chain rule? F of inner function g of x. The prime is outer function prime of inner function times inner function prime. Is right? Yep. So this is the next one. F is like load of outer function. So we have outer function prime. Outer function prime of inner function. What's inner function? Inner function is another composite function g of h of x. So like this times here inner function prime. Inner function is exactly g of h of x. This one prime. So you can use chain rule again. You can just keep f prime of g of h of x times, in this case, this g is another load of outer function. So we have outer function g prime of inner function h of x times inner function prime. That's it. We have this rule. So we call this is what? F is outer. G is middle. H is inner. So what's the idea? Outer function prime times middle function prime times inner function prime. Exactly product of three kind of things. Outer function prime times middle function prime times inner function prime. This is the whole idea. We have like this. Summary of chain rule. The f of g of x prime is f prime of g of x times g prime of x. This is typo. You have to ignore this one. This is typo. Ignore. The g of x to the power n prime is n times g of x to the n minus 1 times g prime of x. F of g of h of x prime is f prime of g of h of x times g prime of h of x times h prime of x. This is whole idea. So let me see. So we think about the 6 examples here. The first one, f of x equals sine cube x. Sine cube x. How can you find the derivative? The sine cube x prime. So do you have any idea? Sine cube x prime, the first one. So like this. So let me see. Was it like a sine cube x? So this is exactly same to so like this one. Sine of x cube. This is what? Sine of x cube. You can change it. This is same to sine of x cube. You're right. So like this. Prime. I want to use this rule. Remember this one? G of x to the power n prime. N is down. G of x to the power n minus 1 times inner function prime. You can use this rule. So what's that? This 3 is like log of n. N is down. The 3 times inner function sine of x to the power 3 minus 1 times inner function prime. So like this. So this is same to 3 times sine of x square times, remember, what is sine of x prime? What's that? What is sine of x prime? Do you know sine of x prime? Do you remember sine of x prime? What is sine of x prime? No? Don't worry. You can memorize this one. So you can find this kind of lecture note in the Carl Schwarz lecture note yesterday. Sine of x prime is cosine of x. Yep, you can memorize this one. So we have cosine of x, like this. So the 2 is going to middle one, change it. 3 times sine the square of x times cosine of x. That's it. This is answer. Right? This is like first one, so like this. The second one, what is sine of x cube? So really be careful. Sine cube x is same to what? Sine of x, this whole thing cube. What is sine x cube? This is sine of x cube. So like so, sine of x cube. So really be careful. So like this. This is same to the next one. Sine of x cube prime. So how can you solve this one? We can use basic chain rule. F of g of x prime is outer function prime of inner function times inner function prime, like chain rule. What's it like log of f? Log of f is here, sine function. So what's f prime? F prime is sine prime. What's sine prime? Not sine 3x squared. What's it like sine prime? Do you know sine prime? Sine prime is cosine. So sine prime is, this f prime is, sine prime is cosine of, here, this important thing, inner function. You plug inner function x cubed into here, times inner function prime. This is exactly g prime of x is inner function prime. So we have cosine of x cubed times what is x cubed prime? Do you know x cubed prime? X cubed prime is, yes, 3x squared. You're right. You can use power rule, 3x squared. Just rearrange it. 3x squared is like going to front. Front, 3x squared cosine of x cubed. That's it. This is answer. Don't like this. Okay, this is some of the idea for solving this one. So I can try one more. The what is tangent of square root of x prime? What do you think? So this one is, we can use Bayesian rule. F of g of x prime is f prime of inner function g of x times inner function prime. This is idea. What's it like log of f? Log of f is tangent. So do you know tangent prime? What is tangent prime? Do you know tangent prime? Remember what is tangent of x prime? Do you know tangent prime? 1 over cosine? Yeah, secant square. Don't memorize. Yes, secant square. Secant square. Tangent of x prime is secant square of x. So tangent prime is secant square. You can write the secant square of, you plug inner function g of x. So g of x is root x. Like this, times inner function prime. Inner function is square root of x. Square root of x prime. So we have secant square of square root of x times. What is the square root of x prime? Same. You can change it to the power form. Prime. You can use power rule. 1 over 2 is down, x to the 1 over 2 minus 1. Same to 1 over 2, x to the negative 1 over 2. You can change it to positive exponent, 1 over x to the 1 over 2. So change it back to radical form. X to the 1/2 is square root of x. So we have 1 over 2 times square root of x. So final answer is secant square of root x over 2 root x. This is idea for solving this problem. What do you think? So far so good? Yeah, this is some of the idea for solving this kind of problems. Yep. So I'm gonna give next problem is third one. The third one. You can try the more problems together. F prime of x is secant of the square root of cosine of x prime. How can you solve the same things? This is the same to what? So you have to use same rule. What's that? F of g of x prime is f prime of g of x times g prime of x. Just use a chain. So here, what is log of f? The log of f is secant. Log of f is secant, like f prime. So my question, do you remember what is secant of x prime? Do you know secant of x prime? Do you remember? Secant of x prime. Do you remember this one? The secant of x prime is, yeah, secant times tangent. You're right. Exactly. The secant x times tan of x. So what is secant prime? Secant times tangent. So you can write the secant times tangent. One more. So this is what? F prime of g of x. So secant of inner function times tangent of inner function. What's inner function? Inner function is square root of cosine. I can erase a little bit more here. So secant of the square root of cosine of x times tangent of inner function square root of cosine of x times inner function. Inner function is the square root of cosine of x prime. The square root of cosine of x prime. How can you find the square root of cosine of x prime? I write here. So here, square root of cosine of x prime, you can change it to the power form. Cosine of x to the power 1 over 2, this whole prime. How can you calculate? We use power rule, is right? Power rule combined with the chain rule. So we have g of x to the power n prime. We have n times g of x to the, 1 over 2 cosine to minus 1/2. Yeah, thank you. This is n minus 1 times g prime of x. So what's that? This is the same to, this 1 over 2 is power n. Power n is like down. 1 over 2. the inner function cosine of x to the power 1 over 2 minus 1 times inner function prime. Inner function is cosine of x prime. This is 1 over 2 cosine of x to the power minus 1/2 times. What is cosine x prime? Do you know cosine of x prime? Do you remember cosine of x prime? What is the cosine of x prime? Do you remember cosine of x prime? Negative sine x, is it right? Yes, thank you. So like this. So this is same to 1 over 2. Cosine of x to minus 1/2 is changed to the positive power cosine of x to 1/2 times negative sine x. You just only change this one to the like this. Minus sine of x is numerator. You can erase this portion. So negative sine of x is numerator. The 2 times cosine of x to the 1/2 change back to radical form, square root of cosine of x. So what's that? This is same to secant of square root of cosine of x times 10 square root of cosine of x times here secant root cosine x prime is negative sine of x over 2 times square root of cosine of x. You can combine. The numerator has exactly negative sine x times secant times tangent is numerator times secant of the square root of cosine of x times tangent of the square root of cosine of x over the denominator is 2 times square root of cosine. That's it. This is the final answer for solving this problem. How can you solve this problem? You have to use chain rule twice. Chain rule twice. This is the idea for solving this problem. So like this. So exactly my previous things, this one. So next tip. First one is the square root of x squared minus 4 over x squared plus 4 prime. So how can you solve this problem? So similar. Only difference is change to the power form first. To the one half prime, this one. So how can you solve? The same. You have to use g of x to the power n prime is n times g of x to the power n minus 1 times g prime of x. So what's that? This is same to here. 1 over 2 is like n is down 1 over 2. We have x squared minus 4 over x squared plus 4 to the power 1/2 minus 1 times x squared minus 4 over x squared plus 4 prime. So how can you find x squared minus 4 over x squared plus 4 prime? How can you find this one? You have to use quotient rule. Do you know quotient rule? Do you know quotient rule? Do you remember quotient rule? Some derivative rule? No? Okay. This is the same, exactly the yesterday lecture, the Kasha's lecture. You can find quotient rule. I can do right here. What's the quotient rule? F of G, like a fraction prime. The top on prime times bottom on minus top on times bottom on prime over bottom on squared. We call quotient. So you have to keep this one. 1 over 2, the x squared minus 4 over x squared plus 4 to the power minus 1/2 times. So what's it like log of f? Log of f is numerator. The log of g is denominator, x squared plus 4. We can use this quotient rule. The top on prime first. So we have x squared minus 4 prime times bottom on x squared plus 4 minus top on x squared minus 4 times bottom prime x squared plus 4 prime, the derivative over bottom on squared, like this. The next is simplify. 1 over 2 x squared minus 4 over x squared plus 4 to the minus 1/2 times. So what is x squared minus 4 prime? What is x squared minus 4 prime? So do you know x squared minus 4 prime? Do you know that, this one? What is x squared minus 4 prime? The 2x, yes, it's the same to x squared prime minus 4 prime. X squared prime is 2x. Constant prime is always 0, just 2x. So we have 2x times x squared plus 4 minus x squared minus 4 times x squared plus 4 prime is similar. X squared prime plus 4 prime, so we have 2x over x squared plus 4 squared. The next, this is 1 over 2. Do you know this rule? Like x over y to the power n. N is like distribute to the numerator, denominator. X to the power n over y to the power n. The same. You can distribute power 1/2 to the numerator, denominator. The numerator has x squared minus 4 to the power minus 1/2 over x squared plus 4 to the power minus 1/2 times, let me see, what's it like here? Distribute 2x. 2x, so what's that? So we have 2x cubed. The 2x times 4 is plus 8x. So one more. You have to move 2x to the front. You can move this 2x to the front. So move 2x here and erase this one. You can move. So you can distribute negative 2x to the x squared. So exactly negative 2x cubed. So negative 2x times negative 4 is positive 8x. So what happens? 2x cubed canceled. 8x plus 8x is 16x. So we have 16x over x squared plus 4 squared. The next, the 2 is common factor crossed out. 2 is crossed out. This is only a. So we have x squared minus 4 to the power minus 1/2 times 8x over. You can combine. We have same base, x squared plus 4 x squared plus 4. How can you calculate? So do you know this rule? So we have x to the power n times x to the power m. Only add exponent n and m. So like this. So this is the same to x squared plus 4. Power is minus 1/2 and 2. You have to add it. Minus 1/2 plus 2. This is same to x squared minus 4 to the power minus 1/2 times 8x over x squared plus 4 minus 1/2 plus 1 is positive 3 over 2. Is right? The next not yet. So you can change negative exponent minus 1/2 to positive 1. How can change? Do you know this rule? So we have x to the minus n is given, change to the positive exponent like reciprocal. What does it mean? The numerator is going to denominator. You can keep 8x over. So this one is going down with positive exponent. So we have x squared minus 4 to the 1/2 times x square of plus 4 to the power 3 over 2. Right? So this is not yet. You can change it to the radical form. You can change it back to radical form. I can change it to the radical form here. This is same to 8x over. So first one, this is same to the square root of x squared minus 4 times square root of x squared plus 4 cubed. So that's it. This is the final answer. So this is whole idea for solving number 4. So I know this is a really complicated problem, but really good exercise problem. Good exercise problem. How does 3 over 2 become 3? Oh, here. So not this one. So do you know? This is like here. Denominator is like 2. So we have, so this part is, I can show later, so like this. So what's that? Here. Previous one is x squared plus, do you know this one? What is x to the 1/2? So we have x because 2 is going to square root. What's x to the 3 over 2? The 2 is going to square root. Power 3 is going to same power. This is like idea. Does it make sense? Okay. Yep. The next one, 5. So how can you find x tangent of 1 over x prime? So here, this is exactly same to x times tangent of x. Do you know this one? Function f times function g prime. So we call product rule. The f prime times g plus f times g prime. You can use product rule. So this is same to what? X is like log of f. So we have x prime times tangent of 1 of x is log of g. The tangent of 1 of x plus. So f times, f is x times tangent of 1 of x prime. You can use product rule first. So what is x prime? Do you know x prime? So what is x prime? X prime is 1. Yeah, 1. Just memorize. X prime is 1. So we have 1 times tangent of 1 over x plus x times. Was it like tangent of 1 over x prime? You can use basic chain rule. F of g of x prime is outer function prime of inner function times inner function prime. So what's that? This is like f is 10. F prime. The tangent prime is secant square. Tangent prime is secant square of inner function 1 over x times inner function prime. Like this. Was it like a 1 over x prime? So here, was it like a 1 over x prime? You can change it to the power. X to the power minus 1, take derivative. You can use power rule. What's the power rule? Power rule is x to the n prime is n times x to the n minus 1, like a power rule. So this negative 1 is lower of n, minus 1 is like down, minus 1 times x to the minus 1 minus 1. So we have negative 1 times x to the negative 2. So what's that? Keep minus 1 times. You can change x to the negative 2 to the positive exponent 1 over x squared. So answer is minus 1 over x squared. So you can change. This is 1 times tangent of 1 over x plus x times secant square of 1 over x times 1 over x prime is minus 1 over x squared. So what happens? 1x is crossed out. So 1 times tangent 1 over x is just tangent of 1 over x plus secant square of x times minus 1 is the negative secant square of 1 over x over x. So we have tangent of 1 over x minus secant square of 1 over x over x. That's it. This is your final answer. This is the whole idea for solving this problem. Like this. So, sixth one. F prime of x is x over square root of 2x minus 1 prime. So, how can you solve this problem? You have to use quotient rule first. What's the quotient rule? I can do right here. The f of g prime is f prime times bottom on minus f times bottom on prime over bottom on squared. Exactly quotient rule. So what's that? top one is x. X prime times the square root of 2x minus 1 minus x times the square root of 2x minus 1 prime over the square root of 2x minus 1 squared. So like this. So what's that? So this is the same to the like this. What is x prime? X prime is, what's x prime? Do you remember? X prime is, yeah, 1 again. This is 1. We have 1 times square root of 2x minus 1 minus x times what is square root of 2x minus 1 prime. I can calculate here. The square root of 2x minus 1 prime is 2x minus 1 to the power 1/2 prime. You can use power rule combined with chain rule. So what's that? Power 1/2 is down like this. Inner function 2x minus 1. You're right. It's good. Don't use square. Don't use square root. Only 2x minus 1 to the 1/2 minus 1 times inner function 2x minus 1 prime. So we have 1 over 2, the 2x minus 1 to power minus 1/2 times. What's 2x prime? Do you know 2x prime? Was it like 2x minus 1 prime? Do you know? Was it 2x minus 1 prime? The 2x prime is like 0? I don't think so here. The 2x minus 1 prime is exactly 2x prime minus 1 prime. The next one, you can take out coefficient only 2 times x prime minus 1 prime is 0. X prime is 1. Exactly only 2. The 2x minus 1 prime is 2. So we have 2 here. What happens? 2 is crossed out. You can change it to the positive exponent, 1 over the 2x minus 1 to power 1/2. You have to change it back to square root form. Square root of 2x minus 1. Okay. Was it like this one? It's the same to 1 over square root of 2x minus 1 over, so 2x, square root of 2x minus 1 square is square and the square root is gone, just 2x minus 1. The next, what happens? This is same to the 1 times the square root of 2x minus 1 is only square root of 2x minus 1. You can change it to the power, the fraction form over 1. The minus the x times 1 is just x over square root of 2x minus 1 whole over 2x minus 1. The next thing, I'm going to simplify numerator. The common denominator of 1 and the square root of 2x minus 1 is square root of 2x minus 1. You have to change first fraction with common denominator square root of 2x minus 1. Like this. This is same to the square root of 2x minus 1 times square root of 2x minus 1. Square root is gone, only 2x minus 1 over the square root of 2x minus 1 minus x over square root of 2x minus 1 over 2x minus 1. You can combine. So you can combine numerators. So exactly 2x minus 1 minus x over the square root of 2x minus 1 over the 2x minus 1. To simplify, this is numerator. The 2x minus 1 minus x is exactly x minus 1. So we have x minus 1 over square root of 2x minus 1 over 2x minus 1. This is like a complex fraction. You have to simplify. Numerator is x minus 1 over the square root of 2x minus 1 times the reciprocal of denominator. The reciprocal of denominator is 1 over 2x minus 1. You can combine. The x minus 1 times 1 is exactly x minus 1 over. The 2x minus 1 times square root of 2x minus 1 is, you can derive. So here, the 2x minus 1 times square root of 2x minus 1. So that's it. This is your final answer. This is the whole idea for solving this problem. Like this. Okay, so what do you think? So far so good? So I don't know. So I think some problems are really difficult, but don't worry, you can practice more. I think you just to totally understand this kind of chain rules. So you need more exercise problems, I think. So next one, find an equation of a tangent line to the curve y equals sine of x at pi 0. So like this. Do you know equation of a tangent line? I can write something here. How can I solve this problem? The first one, we have curve y equals f of x is given. You can choose one point. So x component is a, the y component is like f of a. Here. This is f of a. You can write this point is p. The point p is x component a, y component f of a. I can draw tangent line. Here we can draw tangent line. This is tangent line here. What's like equation of tangent line? The equation of a tangent line is tangent line. I want to use Poincare law form. The y minus y component f of a equals. So what's the slope of a tangent line? Do you know what's the slope of a tangent line? How can you find slope of tangent line? Do you know that slope of tangent line? Do you remember? Delta y over delta x, you're right, exactly. F prime of a, yes. Delta y, the dy over dx, f prime of a, yes. So exactly, slope of tangent line is f prime of a times x minus x component a. This is idea. So from this problem, what is f of x? F of x is sine of x. Here is given function. F of x is function sine of x is given. What is a? What is a? What is a? So do you know a? Pi, yes, pi. So this case is point P is given here, pi 0. Pi 0. This pi is a. 0 is f of a. This is f of a. So we have y minus f of a is y component 0. F prime of a is pi times x minus pi. This is like exactly equation of the tangent line. So you need to find f prime of x. How can you find the prime of x? You can write here. F of x is given. Function sine of x is given. Take derivative. How can you find the derivative? You can use chain rule. Here, do you remember basic chain rule? F of g of x prime is f prime of inner function g of x times inner function prime. So this first sine function is log of f prime. What's sine prime? Sine prime is, what's sine prime? What is sine function prime? Do you know? Sine function prime is, yes, cosine of x. You're right, cosine. So outer function prime is cosine of inner function sine x. times inner function g prime of x, sine of x prime. So cosine of sine of x times sine x prime is here, cosine of x. So we have it. The next, plug pi into f prime. You can calculate f prime of pi. You plug pi into this x, the cosine of sine of pi times cosine of pi. So do you know sine of pi? What is sine of pi? Do you know that sine of pi? The sine of pi is, do you know? 0. So we have cosine of 0 times, do you know cosine of pi? Cosine of pi is, what's that? Yes, -1. What is cosine of 0? Cosine of 0 is, do you remember cosine of 0? Some trig function? Yes, the trig identity, or you can find, you have to memorize like sine, cosine, tangent of angle, the angles. Sine of 0, sine of pi over 6, sine of pi over 4, sine of pi over 3, sine of pi over 2, sine of pi, the next one. You have to memorize this one. So sometimes we call unicircle method. You can draw unicircle, you need to find the exact sine, cosine, tangent values. Yeah, this is very helpful. Cosine of 0 is just 1. 1 times -1. 1 times -1 is -1. You can plug into here. So what's that? This is the same to y equals. This is 0 is going to 0. Gone. F prime of pi is -1. So we have it. The -1 times x minus pi. So simplify. Y equals, distribute -1 to the x and pi, -x plus pi. So that's it. This is exactly equation of a tangent line. Okay, so this is all for today's lecture. So do you have any question? So could you write your question on the chatting board? I'll answer your question. So if you don't have any question, you can leave this live session. Oh yeah, just only, yep. So any question, just write your question on the chatting board. If you don't have any question, you can leave this live session. Okay, thank you. Bye-bye. Oh yeah. So I think you have the basic differentiation rule from Kasha's lecture. The Kasha gave a lecture yesterday, section the 2.3, 2.4. 2.3, 2.4 has basic differentiation formula. The x prime equal to 0, constant prime equal to 0, quotient rule, product rule, sine prime is cosine, cosine prime is negative sine, or something like that. You can find these basic rules exactly the yesterday lecture from the Kasha. Yeah, do you have more questions? Okay, you're welcome. Okay.